A team of British mathematicians and cryptologists working in a secret facility outside of London have successfully cracked the Nazis' most sophisticated encryption algorithm, shortening World War II by 2 years and saving countless lives. But they did all of this without anyone knowing about it until decades later. And even then, for many years, those who worked on the project were forbidden from talking about it. How did they do it? Well, that's what we're going to find out today. But before we get started, now back to the video. The story of how Britain cracked the Nazi code starts here at Bletchley Park, an old stately home that had once hosted lavish parties for members of the British aristocracy. Now it was home to Britain's top codebreakers working for the Government Code and Cipher School, or GCNS. But don't let the name fool you. These guys weren't cracking jokes. They were cracking codes. Specifically, they were trying to crack Enigma. You see, since the start of the war, the Germans had been using a device called Enigma to encrypt their communications. Enigma machines were essentially typewriters that could be set to a virtually infinite number of encryption settings. Every letter of the alphabet was paired with a different light. When the operator typed a letter into the machine, that light would flash, but it wouldn't flash the letter that was typed. It would flash the letter that the typed letter corresponded to in the machine's encryption table. So if the machine was set to the letter A, which was paired with the letter Z, typing A would make the letter Z light flash. And if the operator wanted to send the letter Z, they would type Q, which was paired with Z, as you can probably tell. This made the messages extremely difficult to decipher, which is why the Germans used them so extensively. The British knew that to break the Enigma code, they needed to know 3 things: the plain text letter that was being encrypted, the encrypted ciphertext, and the settings. 8. That the machine was set to when the message was sent. If they could figure out how to get this information, they could input it into another Enigma machine and voila, instant decryption. But figuring out how to get the necessary information was easier said than done. Enter Poland. At the end of August 1939, just weeks before the start of World War II, the Poles managed to capture a working Enigma machine, along with thousands of encoded messages. They then brought these to the British and French and shared with them everything they knew about Enigma, which wasn't everything, because they hadn't cracked it yet. Then they asked the British and French for a little favor, specifically to not use Enigma to decrypt the captured Polish Enigma messages. And since the British and French didn't yet know how to operate Enigma, they agreed. Upon further inspection, the British found that almost all of the captured messages had been sent at 6 a.m. every day, indicating that they might contain routine military reports, like troop movements or orders for the day. What they also noticed was that there was a great deal of repetition in the messages. So much so that they realized that the Germans were using a fairly predictable rotor configuration for each time. And location, meaning that with enough time and effort, it should be possible to brute force the system. So in September 1939, the British began testing the captured Enigma machine, trying to guess the right rotor settings for a given message. However, it quickly became apparent that doing this manually would take far too long, and so they turned to mathematics to help them out. See? The thing about math is that it makes the world around us much more predictable. By applying mathematical formulas, we can describe how things change over time, how they interact with other things, and most importantly, for codebreakers, how they might be decrypted. So the British mathematicians at Bletchley Park got to work building a device that could calculate the odds of any given set of letters being encrypted into a given set of flashes. Basically, they were creating a calculating machine that could test every single possible combination of the Enigma settings and compare them to the captured messages until it found the right match. And when I say calculating machine, I mean something much simpler than what we would call a computer today. In fact, the machine that they built, known as the bomb, was really more of a glorified typewriter that could manipulate paper tape to represent the Enigma rotors and settings. It would then simulate the process of sending a message through Enigma, comparing the simulated output to the actual output of the captured Enigma machine to see if they matched. If they did, then the bomba would move on to the next message. If not, then it would keep trying the same set of settings until it got it right. There was just one problem, though. It didn't yet know how many possible settings there were to try, which meant that the bomb could go through the possible combinations endlessly without ever finding the right one. Luckily, the Poles had done some research and provided the British with a list of approximately 800 potential starting settings. This gave the bomb a manageable number of combinations to try, allowing it to decrypt its first message on November 1939. At this point, the British were able to determine that Enigma messages from the Danzig naval base only contained weather reports. And while this was hardly the stuff of James Bond, it was a start. The real test would be cracking the naval Enigma used by U-boats. Fortunately for the Allies, the Germans changed the naval Enigma's rotor configuration every day, which made it much easier to decrypt. In fact, with a bit of luck, it only took the Bomba a few hours to crack each day's new settings. Over the course of the war, the German Navy would send over 50 million messages using Enigma. And thanks to the Bomba, the British were able to read every single one of them. This intelligence would play a major role in the Battle of the Atlantic, allowing the Allies to track U-boat movements and providing valuable information about German tactics and strategy. In fact, it is estimated that the Allies would have lost the war if not for the work done at Bletchley Park. That's because Enigma was used everywhere in the German military. Messages containing battle plans, troop deployments, shipping routes, and even Hitler's personal correspondence were routinely sent through Enigma. Unfortunately, though, the British couldn't decrypt these messages. Not yet, anyway. See, the reason that the bomb was able to decrypt Enigma messages was because the Germans changed the settings every day. If they didn't, then it would take months rather than hours to decrypt a message. But the trouble was that the Germans never sent messages that remained unchanged for long enough for the British to decipher. That is until February 1942, when the British received a shipment of captured German military manuals. These manuals contained hundreds of messages that remained unchanged for days, weeks, even months, including German military codes. Having access to these codes allowed the British to tap into high-level German communications, giving them insight into the inner workings of the German military machine. They learned that Germany's top-secret plan to invade the Soviet Union, known as Barbarossa, was just weeks away. With this intelligence, Winston Churchill convinced the reluctant Joseph Stalin to declare war on Germany, breaking the non-aggression pact between the two nations and bringing the Soviets into the war. The British would continue to use the bomb throughout the rest of the war, decrypting important messages and providing the Allies with a decisive edge over the Germans. But as soon as the war was over, they shut down the operation and put all of the Bomba's blueprints under lock and key. For the next 30 years, those who worked at Bletchley Park were forbidden to talk about their experiences there, not even to their family and friends. The secrecy surrounding the park was so tight that many people who worked there spent the rest of their lives believing that the war had been lost, so that future generations could live in a world where code breaking was unappreciated. It wasn't until the 1970s that the British government finally declassified the history of Bletchley Park, revealing the contributions of the brilliant mathematicians and codebreakers who had operated the bomb. Since then, Bletchley Park has become a museum dedicated to the work done there during the war and the legacy of those who made it possible. I hope you enjoyed learning about one of the most important code-breaking operations in history. If you did, please consider subscribing. And as always, thank you for watching.